Okay, 6.2.3. First, well, we need to list and completely factor all the monic quadratic polynomials over Z3. So a monic just means that it's a 1x squared, blah, 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 blah. It's a 1 right there. All right, so first thing we do is we just list everything. So here are all of them listed. And I kind of thought of this as like a coordinate system. Like this was 0, 0. This is 1, 0. This is 2, 0. Get what I mean? This is the 2x plus, x squared plus 2x plus 0. X squared plus 1x plus 0. Okay, so we listed them all out. And from there, we'll list all the elements of degree 1. And so that's going to be x plus 1, and x plus 2. And we'll use these later. So now, if one of these polynomials is not divisible by any of these, it must be prime, right? So if you have a second degree and it's not divisible by any degree 1, then it must be prime, right? So then what we do is we just factor all of these really quick. Now all these, like just an x squared right here. It's not a big deal. And then this one is going to be factor out an x, right? And then this one we factor out an x. And now we're left with everything of degree 1. So degree 1, degree 1, degree 1. And so we know we're done factoring. Okay, so let's keep going for that second row there. So I want to factor this one. Oops. I want to factor that one. Now let's try to factor it by dividing it by all of these ones that we talked about before. These ones, x plus 1, x plus 2. Okay, so we know it's not divisible by x. Well, we can try. Here, let's just go for it. X squared plus 0x plus 1. Now, I'm just going to try an x. So x here, x squared, and then we get a 0, 0 plus 1, and then we can see that we're going to be left with a remainder. Okay, so then let's try x plus 1. X plus 1, and put an x here. Okay, x squared plus x, 0. Now this is going to be negative x, right? Negative x. But in Z3, that's going to be 2x plus 1. So then plus 2. So we get 2x plus 2. That's going to be negative 1 again, which is 2. Okay, so we're going to have a remainder. All right, let's try the next one. So that's going to be x plus 2. So x squared plus 2x, 0, negative 2x, right, which is going to be positive x in Z3, plus 1, plus 1, so x plus 2, negative 1, which is 2 again. All right, so we can see we again have a remainder. So it's not divisible by any degree 1, so it's not divisible by anything. So this must be prime. And so we can't factor it. Then I want you to think of another thing. So when we're dealing with these, we can take all the combinations of these ones, right? So let's just think of these two, the x plus 1 and the x plus 2, since we've already taken care of all the x's. So x plus 1, multiply that out, and you get x squared plus x plus 1, right? X squared plus 2x plus 1, all in Z3. Now we can just go and find that really quick. X squared plus 2x plus 1. That's going to be right here. And so there we go. It's right here. And we can keep going like that. Then we can say, well, let's do a x plus 1 and an x plus 2. Okay, so x squared plus x plus 2x plus 2. X squared plus 3x plus 2. And then actually that's an x squared plus 2, right? In Z3. So then we can go and look for that one. X squared plus 2, which is right. X squared plus 2. And sure enough, it's right here. And then we can look for, how about x plus 2 multiplied by an x plus 2? X plus 2, x plus 2. So that's going to be x squared plus x plus 1, right? And so right there, that's going to be, where's the x squared plus x plus 1? X squared plus x plus 1. It's right there. And sure enough, yeah, it's x plus 2, x plus 2. All right, so then we can just keep going like this and find more and more. Although that's all of them, right? So x plus 1, x plus 1, x plus 1, x plus 2, and finally an x plus 2, x plus 2, and the rest should be prime. And sure enough, they are. So if we check these are going to be prime. Or these are going to be prime. And that's it. So there's kind of two different ways you can do it. You can divide it and do it that way. Or you can just think of new possibilities, or possibly all the possibilities, and then you know the rest are prime. Still, though, I think it's good to check the ones that are prime, just to make sure.